All right, so how's it going today?
It's okay.
So I'm going to pass around the sign-in sheet. Go ahead and sign in. I'm going to use the same sheet for a few days, and then I'll print out a new one to let people add in the course and so on.
You use the same sign-in sheet for last class too?
Same names, but a different sheet.
Oh, okay.
But like I'm having people write their name on the bottom if they're not on the list, but it's going to have to be that way for a few days, and then I'll update it. So how's everything going?
Great.
Good? Okay, cool. So I had a bunch of emails from people who could not get logged into the server yesterday. I've either responded to you with creating an account and telling you that, or resetting your password if you asked me to do that, or telling you that you already had an account and reminding you how to log in. If you still cannot get logged in, right, send me an email. Discord can get lost in the shuffle, so if you need to make sure that I see something, send me an email and say, you know, I still can't get logged in, or I forgot my password or something, and we can reset that accordingly. All right, good. So I think everybody has access at this point. So let's see, a few things I wanted to mention. I don't think I mentioned this in here yesterday. So we meet for an hour a day, 5 days a week for 11 weeks, right? That's 55 hours of listening to me talk. That's a long time, okay? And I don't usually just say things at random just to make noise. Usually there's a reason for everything that I'm saying up here. So in some sense, everything I say is important, okay? But some things are more important than other things, okay? A lot of stuff will get repeated again and again and again, so if you're zoned out, not a big deal. But sometimes I'll say something like, okay, this is definitely going to be a question on the final exam, and then I'll give you an example. That's a good time to pay attention, okay? Or I'll say, most likely when you try to do this, you're going to make the following mistake and it will cost you 5 hours. I'll tell you how to avoid that now. Okay, that's a good time to pay attention. So I knew a professor who would stamp his foot 3 times when he wanted people to pay attention. Okay, and I don't want to stamp my foot. So occasionally while we're lecturing, you'll see something. You'll see something like this pop up on the screen. Okay, that's your subtle clue that something important is happening.
Subtle.
Okay. And so I'll try not to overuse that, but you know, if I'm about to say, here's the answer to half the questions on the exam, right, we'll pop that up.
Will you do that?
I sometimes tell people this is going to be an exam question, right? I don't see why an exam should be an exercise in reading my mind or predicting my mood. You know, Engineering 250, you've got to be able to just analyze a state machine. That's always going to be a question on my 250 exam. It's not a secret, it shouldn't be a secret. So, yeah, there's things like that in here that you'll see also. But not all of it. All right, next thing I wanted to mention, Engineering Computer Science Club. If you don't know about this club already, I want to mention it here. Meets every Friday at noon in room 126. It's the room down the hall right around the corner. And it's a student club. It's run by students for students, and it's basically whatever the students decide they want it to be. But nominally, it's a place to get together and hang out with fellow engineering computer science students and do whatever you want. Kick around ideas, talk about things you're working on. If you're doing an SLP and you need someone to work with, you could, you know, make a pitch to say, hey, if anybody's interested in such and such, talk to me about it. And it takes lots of different shapes and forms. They do field trips sometimes. They decided they wanted to visit the nuclear reactor at Reed College one year, and so they arranged to do that, and they figured out how to do it, and someone offered to give them a tour, and they drove up to Reed College and got to see a nuclear reactor. And that's not because Izad or I said, hey, let's go to Reed College, because the students decided that's what they wanted to do. There was one year they had pizza delivered for every meeting. Why? Because the students decided, let's spend part of our money on having pizza for our club meetings. And so they did that. So it's really up to the students, okay? But it's a great resource in terms of networking, in terms of kind of hanging out with people doing similar things to what you're doing as far as what they're studying and stuff. And you know, you want to do game development, you're trying to learn Unity through some online tutorials, and you'd like some people to work with. go into the front of the club and say, hey, here's what I'm doing. Is anybody interested? If so, come and let me know, and we can start meeting together and stuff. And it's just kind of a networking, collaboration, socializing kind of opportunity. So that's Fridays at 12 o'clock, room 126, starting this Friday is the first meeting. And there's no obligation. You don't have to like join or anything fancy like that. Just show up and participate however you like. Stay as long as you want. All right. Another thing that I think I forgot to mention in here yesterday, there's an optional C-text that I posted a link to. It's a PDF version of this, which is called I Can See Clearly Now. I know it's a bad joke, but a good song. This is my attempt, after having taught this course and taught C for a number of years, to try to address a bit of a gap between the following situations. One, I know how to program in C. I understand the syntax. I can write code that compiles successfully. I know what the fget statement does. I know what if means. I know what while means. But when somebody asks me to write a program to play tic-tac-toe, to write a program to take a set of numbers and calculate some statistics on them, to do this, that, or the other thing, I have no idea how to do that, right? I understand the tools, but I don't know how to put them together. I don't know how to build up something larger from these simple pieces. That's what this is really trying to address. And so it's 8 or 9 chapters that basically drill down into very specific details, specific algorithms, methodologies for doing things mainly in C. That let you work towards bigger things. So parsing, right? You know how to read input with fgets. You know about scanf. But how do you take that and build a command interpreter that lets the person type something like set x equal to 12 and have your program respond to that, right? That's what we call parsing. So there's a chapter on parsing, and there's one on all about string processing and stuff like that. Thank you. If anybody didn't sign in, come in and sign in at the end of class, please. So this is up there. It's free. It's about 100 pages. It's a PDF, and for what it's worth, there it is. So if you want to take a look at that, if you're feeling stuck on things, if you're not quite sure about recursion, you want to read some more about it, or we haven't talked recursion yet, but when we get there. So I just want to mention that's available up there. So that's under optional C text. All right. So how many people have successfully done the one-day program? Cool. All right, so if you haven't started that yet, start it like yesterday. Go back in time. Start it. Start it as soon as possible, right? If you've started it and you're having trouble with it, shoot me a note or post a discussion on Discord. Okay. Preferably Discord in general, but since this is due tomorrow morning at 8, you might want to shoot me a note also. But we went through this yesterday, right? The process for assessing. So hopefully everybody can get there. And then tomorrow morning at 8:05, the next ODP will open up, and we'll talk about that in class and go through some examples of it and such. Yeah.
I'm having troubles getting onto the Linux server.
Ah, okay. Did you? What sort of troubles?
It says could not resolve host name. Is temporary failure in name resolution.
What's the host name you're trying? Are you on the network?
Yes.
Are you positive?
School network?
Yeah.
Yes.
Like, can you get to a web page other than a Clark web page?
Yeah.
They just tried to pull the server.
Like, just try a random, like, you type gibberish in your address bar. Or that. Okay. Let me see what you were trying to connect to the server again. It also looks like I can't ping Google.
Maybe the terminal just didn't have access.
Huh, okay.
Yeah, so it's something in the setup. We can look at it later.
Okay.
But you're doing it the right way.
Got it.
That would work if it was working. All right. So I want to talk a little bit about Linux. Okay, get into some of the background on Linux. Give you some examples of the kinds of things we're going to be working towards. And then when we've got a few minutes left, I want to go through a bit of Git to make sure that you've got a head start on the homework that's due on Friday. And once you know how to use Git, the homework takes you a few minutes to do. It's just going through some steps. But I want to start doing that towards the end of the class. And then tomorrow we're going to start talking about shell scripting. Okay, so your first programming assignment is a program that's not written in C, it's written in what we call a shell script. And we don't assume that you've done shell scripting in this class, so we're going to go through everything you need to know to do that. That'll be our first 1 or 2 weeks of the course. But let's talk a little bit about Linux first. And so the original version of Linux was called Unix. Unix was developed in the early 70s at Bell Labs. Okay, that was the research wing of the phone company. And it was developed originally for internal use at Bell Labs. And you'll hear names like Kernighan and Ritchie associated with C and Unix and stuff. It was a project that started small and it really kind of like caught hold and took off and became a big thing. Became something that Bell Labs offered commercially to other people to use. And through the 70s and 80s, Unix was a commercial product and it was fairly expensive. It was really expensive to get the source code. So it came to you, you know, like Windows, you could run it, but you couldn't see what actually made it work. You couldn't see the actual code that went into making the system. It was closed source. In 91, somebody started working on their own version of Unix. They wanted to make a version of their own that would tap into the operating system, into the file system on their machine. And it was just a little pet project they were doing. They said they didn't expect it to be anything major, just a few commands and stuff. And this turned into Linux, and it just totally took off. And part of the appeal of Linux was that it was open source. Okay, the people who were developing this publicized the code that they were writing. And so I'm running Linux on my machine here, right? This is Linux. And if I say date, right, it shows me what the current date is. I can find the C code that was written to make that happen. And I can copy it, and I can modify it if I want, and I can redistribute it if I want. And I can do whatever I want. I can make my own version of Linux. This is why there's so many different versions or distributions of Linux. There's Ubuntu, there's Mint, there's all sorts of different versions. Because the source code is open, right? And this is a good thing, in my opinion, right? I've switched over. All the work I do is totally open source now. I let my patents expire. Everything is like just totally published out there. Why? Because if it's open, you've got, you know, potentially 7 billion people working on this project with you. If it's closed, you've got whatever the size of your engineering team is. And that's a huge difference, right? And my engineering team is going to develop a product based on the idea that's in their brains or in the brain of whoever's giving them their direction. Well, that's one vision, right? If this is out there for anybody who's interested to develop, you know, a 13-year-old in India might take this and turn it into something totally different and amazing that I just wouldn't have thought of because that's not where my brain is. And I told my team, this is what we're going to make, right? And this happens all the time. This is how technology is developing. This is where Google came from, right? Google wasn't, you know, some sort of corporate decree from some huge entity. It was two people who were like, search kind of sucks. Let's figure out a way to make it better. YouTube, all this stuff, right? So I'm a big fan of open source stuff, and Linux is open source. So Unix, Linux were originally designed around some key philosophies. One idea was to make the system very modular. So a lot of operating systems, CPM and VMS and all of these things, they're these programs that run on your computer and let you send commands to them to say, you know, show me the files on my system, show me who's logged in, show me what folder or directory I'm sitting in, right? And the operating system has all these commands built into it, right? Unix, Linux, and I'll use the term Linux mostly, it basically means the same thing as Unix commercial version. Linux really has very few commands that are inherent to the operating system. When I say date, on any Linux system, it's going to show me the date, but date is not a part of the operating system. Okay, if you just look at the Linux kernel itself, there's nothing in there that says when I say date, you should show me the day of the week, the month, and so on and so forth. It's a very simple operating system, but it's extendable. It's extendable because if I type something in that the system does not understand, it's going to assume I'm typing in the name of a program, and it's going to run that program for me. And date is the name of a program. And when I say date, there's a program running, and that program is what prints out the day of the week, the month, and so on and so forth. And I can say, where is date? And it'll tell me date is in this directory called /bin. Okay, it's a folder, if you use Windows lingo. /bin is a directory, it contains a file called date. And when I say date, that program's running. What is that program? It's something that was written in C and compiled, and that's the executable version of it. And it's just a C program. It's a program that by the end of this course, probably any of us could write. If I say ls, that shows me all the files that are sitting in my current directory. What is ls? It's a C program. And where is it? It's also under the /bin directory. So ls is not an inherent part of the Linux kernel, but if I say ls on any Unix system, the person who put that system together will make sure that there's a program called ls somewhere like /bin, and that's what gets executed. So it's just a big program written in C. When I say GCC to compile a C program of my own, what is that? Is it part of Linux? No, it's just a program. What is GCC written in? It's written in C, which is kind of cool. So they had to run it on itself to compile it the first time. But it's just another C program that happens to be written so that if it takes a set of input, it looks at it as being a C program and it figures out what should I turn this into, what are the right ones and zeros, so that this thing will run and act like a program that does what this source code does. Compiler writing is a whole nother course, and it's a really fun topic. So there's all these Unix commands, but they're not really Unix commands per se. They are in the sense that they're standard, but they're really just programs. And if I say ls/bin, it will show me all the things that are inside that bin directory. All of these things are commands.
That's a lot of commands.
That's a lot of commands. And there's /usr/bin, that's got even more commands.
Yes. There's a yes command.
There's a yes command. What does yes do? It says y over and over and over again. Or you can say yes, no, and it'll say no over and over and over again. That's useful because a lot of times you're doing things and, you know, computers sometimes they want to get really chatty with you. You want to delete 12 files and it's like, do you want to delete this file? Do you want to delete this file? Do you want to delete this file? And you get tired of saying yes, 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 yes. So you can use the yes command and say, instead of asking me, just ask this program for my answers. And every time that it asks, it'll come back and it'll say y, which means yes. Or you could say yes, no, and say my default answer is no.
And would you just pipe it to yes?
Yeah, if we know about pipes, which we're going to talk about. And if you're not sure what yes does, you can say, show me the manual page for this command yes, and it'll tell you all about it. We'll spend more time looking at manual pages, but I'll just throw that out of the teaser. I'll put a string repeatedly until killed. All right, so modular design, small pieces with well-defined functions. And there's a way to put these pieces together to work with one another. So this is something we're going to call a pipe, and we'll spend a different class. We'll start talking more about putting these commands together. But I'll show you a few examples right now, just to kind of illustrate the point. Another part of Unix was the idea of a unified file system. Okay, so one thing I like to say: everything in Unix is a file. Okay, we know what files are when we make the homework 1.c. That's a file, okay? But there's other files as well. For example, there's a directory called /dev, and it has all of these files in here. Well, guess what? Most of these things are actually pieces of hardware. They're interfaces to hardware devices. TTY is an interface to something with a keyboard and a display, typically. If I plug something into my USB port, I'll see something called TTY USB 0. That's how I talk to whatever is plugged into my USB. But guess what? It's just a file. And anything I can do with a file, opening it, reading it, writing it, setting permission bits to control who has access to it, I can do to any file, whether it's just a file of characters or it's an actual hardware device. So this is a kind of cool idea, and it's pretty central to Unix. And the other idea is this idea of a shell. So right now I'm sitting here and there's a blinking cursor, which usually means it's waiting for you to do something. There's what I call a prompt. So my prompt is a pair of angle brackets with a number in between. That number keeps increasing. If you go on to let's hop onto the Linux server as Goblin King. If we go on there, the prompt is my username, @ and localhost, :, a tilde, and a $sign. And every time that I'm doing something and it's waiting for me to type something, I will see that prompt followed by a blinking cursor. And it means it's your turn to say something. So I can say date, and it'll respond, and then it says, I'm waiting for you again.
Can you try and log into another server while you're in the server?
Yeah.
That's wild.
Yeah, so you can SSH and hop into wherever.
Okay.
And you can go back and forth, or you can log in as yourself. So what's happening here? How is it that this machine is sitting here waiting for me to do something? Where are those instructions coming from? It's a C program. In this case, it's a C program called bash, B-A-S-H, which is an abbreviation for the born again shell, B-A-S-H. SH is an abbreviation for shell, which was the name of an early shell or interface to the operating system. And it was called the Bourne shell, B-O-U-R-N-E. And so Born Again shell is an updated version of it. So there's a program running on my machine right now called bash that printed out 2017 in angle brackets and is sitting here waiting for me to type something. And one of the commands we can use is something called PS. This is another C program. And PS says, show me all the processes that are currently running associated with this session. And it showed me 2 lines of output. Well, it showed me a line of headers and then 2 lines of output. One of them says bash. That's the shell that's currently running. That's the program that's running right now that printed all this out and is waiting for me to type something in. Right, so all of this has been produced by bash. There's a second line here which says there's a command called PS. That's the command that I started executing right here when I said PS. Right, so it's running PS and it's showing me, oh yeah, and there's a process called PS. And this first column is a process ID. It's a internal number that identifies every process on the system. And if I say PS again, bash is still out there. It's got the same process ID, 25115, but the process ID for the PS command is different because this is not the same PS command as that one. Right? This was the one when I typed it up here. This is the one when I typed it down here just now. And after it finished printing this out, the process went away. So if I could look at the processes without having to type PS, I wouldn't see that second line anymore. Right? It's gone. So we'll spend another few classes sometime talking all about processes on Unix. And there's a lot we can do with processes, and in the end we'll actually learn about how to create processes and communicate between processes and so on and so forth. But this is just kind of easing into some of these ideas. You can kill processes too. So I can say kill, and if I kill this bash process, which is 25115, I just killed my shell, and I can't do anything anymore. I mean, I can type, but nothing's happening. I can start there. All right, so we've, yeah.
Is there a reason why it starts at 1999?
Yeah. So I have this set up to show me, to record a history of commands, and I can say history, and it'll show me my last 2,000 commands. And it always cuts off at 2,000. That's just what I set it to. So it always starts from command 1 all the way up through 2,000. And so it makes my current command 1999. That's just the first one I'm going to type in. It's just what I set the limit up to, and the fact that I've got it recording history.
Realistically, do you ever need the last 2,000?
Maybe once or twice I've had to actually go back really far.
Okay.
But 2,000 is just kind of, you know, it's free, so. What was I doing 2,000 commands ago?
PDF.
Oh, it's only set up to do 1,000 right now. So that wasn't all that long ago, actually. I don't remember what I was doing.
Was that summer?
Yeah, but I think it was only like a week ago.
Dang.
Was it when you were using your command for these?
Yeah, yeah.
Huh?
I think so. Yeah, do some math sometimes and add up like how many hours you've spent writing code in your life, or how many for loops you've done, or how many times you declared integer I, and it's an interesting way to track your life progress. All right, so I'm going to say SSH $Linux, and guess what? That just logs me into the Linux server with no fuss, no muss. So normally I would say SSH nick at linux.engrcs.com. So my username is Nick because I set that up a long time ago, and so everybody else, your username is first initial, last name. Mine is just Nick because it's less to type. So normally I would type SSH nick at linux.engrcs.com and make a bunch of typos on the way, right? So what did I do? I created a bash variable called Linux, and the value of Linux is nick at linux.engrcs.com. And now I can just say SSH $Linux, and it acts as if I had typed SSH nick at linux.engrcs.com. Does that, like, you know, double the amount of free time I have in my life? No, but it saves me a little bit of time, it saves me a little bit of thinking, it saves me a little bit of frustration, and that's huge for me, right? So I told the other class, my mantra with computers is two-pronged. Don't waste my time, don't get in my way, right? I'm using a computer to do something, to write a book, to prepare notes, to do some research, right? I don't want it asking me to do things that I don't want to do, right? So I wanted to do what I'm trying to do and just sort of stand out of the way other than that. So this is one way that I can avoid, you know, spending more time than I want to. I just say SSH $Linux. The other thing is I don't have to type in a password. Okay, I've set up a secret handshake between the server and my laptop so they can authenticate and know who each other is. And you can do this. It takes, you know, 2 minutes to set up. And now if I'm on my laptop, I can just SSH directly to the server. Now if I lose my laptop and someone knows this, that's a bad thing, because anybody who has physical control of this can log in. But, you know, trade-offs. So I can hop into the server like this.
You've told every one of us.
Yeah, yeah.
Yeah.
All right. So PS, I've got two processes running here too, bash, which has a different ID, and my PS command. I can say, show me the full listing of processes for a user whose name is Nick, and it'll show me all the processes associated with this person named Nick. That's me, right? And there's the bash process, and there's the PS process, and there's all these other processes sitting out here. There's a job that's sleeping for 1.1 million seconds. And here's something called Java Server ODP 401. What is that? Well, that's the thing that's running the back end of the assess command. So when you say assess, it's talking to this process, which is running something called server, which is a Java program. And I've got it set up so that Wednesday, ODP 402 is going to start. That's tomorrow. And it'll start running the server to assess ODP 402. So I've got several ODPs queued up here ready to go, and they're each sleeping a certain amount of time so that they start on the right moment. And that's all automated. I don't type all that stuff in. If I say ps-elf, E is kind of like everybody, show me a long format. That shows me every process on this system. And there's a lot of processes out here. So here's all the ones that, or a bunch of them that are being used by Nick. Here's some ones being used by root. And there's some users who are logged in doing things, right, so we can see them. There's also a lot of processes owned by root. Root is the system process. Okay, it's the privileged user, and it runs system commands. For example, the thing that's serving up web pages when you go to linuxengrcs.com is a process that's owned by root. And it's sitting out there and it's waiting for requests to serve up web pages. So this is everything that's running on the system. Okay, suppose I want to know how many different users are currently doing things on this system. Well, there's Nick, that's 1, there's root, that's 2, here's 3, there's 4. I could go through and I could count these by hand. That's a pain. Okay, there's probably a command that will do this for us. There's switches you can put on commands. For example, when you say PS, it does this. I can say PS, and I can put some switches on here, some things that modify it. You type a dash followed by some cryptic code, and it modifies what the command does. And there's probably a switch that I could use that would tell me how many different users are running processes on here. I don't know what that switch is. Okay, but I can find the answer to this question really easily. Yeah, I could look at the man page for it, but the man page for PS is fairly long. And there's lots of switches to deal with, and that's way too much work for me. So here's the idea, right? We're going to learn a small amount of Unix. Unix is this big thing, right, with zillions of commands. We're going to learn a small subset of those, but we're going to learn those really well, and we're going to learn how to put them together. And here's one way we can put things together. We can use what's called a pipe. And we'll spend, later in the course, we'll talk a lot about pipes. But let me just give you some motivation for why this is useful. We can take a pipe, and a pipe will basically say, let me run one command and take that output, and instead of showing it to me on the screen, use that as input to something else. Okay, so there's a program called awk. We'll spend a few days talking about awk at the end of the course. Awk lets me say something like print $3. And this will read input from here. This is a test, and it'll print out whatever the third word is on each line. All right, so that's one thing that awk does. So if I were to take this output from PSELF and I were to say awk print $3, what would I get? I'd get a list of just the usernames, the people who own each process. So I'm going to say ps-elf, and I'm going to use this vertical bar, this thing we call a pipe, that we'll spend a long time talking about later. I'm going to put that into awk. This combination of things should show me the output of ps, but just the third column, the usernames. So this is a little easier to go through and count up the unique names that I find in here. But you know, these names aren't all next to each other, right? There's a root down here, there's a root up here, there's a root way up here. It would be easier if these names were clustered together next to each other. And one way to do that is to sort everything. So I can take this output, and instead of displaying it, I can say feed that to this program called sort, which takes input and sorts it. And now my output is alphabetized. And this is pretty quick to work with. I just have to count the number of groups that I see. But that's still a bit of a pain. Well, there's another command called unique. And what unique does is says, look at your input, and if your current input's the same as the previous input, ignore it. Don't print it out. So A Kennedy, A Kennedy, A Kennedy, A Kennedy, it would drop 3 of these and only print out 1 of these. So if I take this and I pipe it into unique, there's a list of all the unique people who have processes on the system right now. And I could count that up pretty easily. Or I could pipe that into something called word count, which one of the things it does is it tells me how many lines of input did it see, 17 lines. So this one command tells me there's 17 people running processes on the system. Okay, that took like 5 or 10 minutes to go through, but once you understand this small set of commands, ps, awk, sort, unique, word count, date, echo, read, a few others, 20 or 30 commands, and you're fluent in using these pipes to connect things together, this becomes second nature, right? And you want to know how many people have assessed their ODP already, you cobble together a line like this and you barely have to think about it. And if you do this a lot, you put it inside a file as a shell script, and instead of typing all this in, you just type in the name of the shell script. So I'll do a bit of magic here without going into a lot of detail. All right, so now I've got a file in here called Go. Anytime I type Go, it does all of that stuff that we typed up there. Why? Because Go contains a line that says do ps, pipe it into awk, pipe it into sort, and so on. Well, I just made myself a new command. I could call it something better than Go, like user count or something. And I type that, and it does this for me. So we're constantly sort of extending our Unix environment. We're tailoring it to what we need to do. And if this was something I needed to do a lot of, right, I would have a command like this. All right, so main ideas, right, small set of commands. We're going to learn them really well. We're going to figure out how to put them together. We're going to build toolboxes, basically. We're not going to have every hammer that Home Depot sells in our toolbox. We're going to have a claw hammer and a ball peen hammer and maybe something else. And we're going to get really good at using them, okay, and putting them together. Does that make sense?
Yeah.
All right, so let's talk about Git. To get going on that, and we'll finish up talking about Git tomorrow. But Git is this idea of source code control, okay? Being able to keep track of changes to our projects in a reasonable way. So on the how-to, page 5 through 7 is about Gitlab. And there's a small snafu in here. You can't actually do all of this stuff until you do this stuff down here. So in general, I would just jump down to doing the initial Gitlab setup, do this stuff, and then go back up here. And I'll update this when I get home tonight. But let's run through this and see what happens. We'll go back to Goblin King, which is pretty much a totally clean setup. All right. So this how-to has a reminder about basic Unix commands. We'll spend some time going through Unix commands in here, but you've done some of this in 121, and so I'll go through some of this pretty quickly, and we'll come back to it and make it clearer. But first thing is we're going to use this server for a number of classes, 224, 222, 223, and 215. Okay, so I don't really want to do everything in one directory. Right, if I make every file in one directory, I'm going to end up with 500 files in here, And every class is going to have a programming assignment 1, so I'm going to have to make sure I don't get them confused. So we're going to work with subdirectories, okay, folders. And so the first thing I might do is make a folder just for this class. So right now there's nothing in my directory. I'm going to say make dir 224. And now there's a folder called 224. And I can go into 224, and that's a separate directory. It's got no files in there right now. I want to play around with some Git. I want to play around with some source code control. It's just practice. It's just junk code right now, right? So I'm just going to make something called gitwork1. And I'm going to cd into that. So I can say print my current working directory. Okay, it's /home / my username /224 / gitwork. That's the directory I'm sitting in. And I'm going to make a readme. And I'm going to make a main.c. And now I've got 2 files sitting under here. Okay. If I go back to my original login directory, I don't see those files. I just see this directory called 224. And if I go into change directory into 224, I don't see those files. I see a directory for gitwork1. There might be project 1 and homework 1 and ODP 402, and I could have all these different directories in here. But if I go down into gitwork1, I've got 2 files sitting in there. All right. So so how do we do Git? Got to do some one-time setup. And so there's 3 commands you have to do. First one is to decide what kind of editor you want to use when you're putting in messages when we commit. We'll see this in a second. So so I'm using VI, so I'm just going to type in this command which says git config global core.editor, and this could be VI or Nano or whatever your editor is that you choose to use. I'm just going to use VI.
And that seems like you can change that anytime.
You can change that any time, but you only have to set it up once. There's a default editor, but it's not VI. But this is a one-time thing. You don't have to do this more than once. Even if you work in different directories and stuff, it's once per machine. Okay, so as long as I'm on this laptop, it'll remember this choice. And then there's these other things that should be up at the top, which I'll move later, which is telling the Git system what your username and email are. All right, so I'm going to use my Nick Macias and my email, and it doesn't hurt to put things in quotes if you're using weird characters. All right, so that's my one-time setup. I'm good to go. Okay, so once per project, you need to do the following. You need to say git init. And this is why it's important to be in your own directory for each project. Because when you say git init, things are going to happen in that directory. So let's say git init, initialize an empty repository under 224 gitwork1 that says /.git. Now if I say ls, nothing seems to have changed, nothing's happened. But there's a switch you can put on ls which says show me all of the files, including ones that begin with a period. These are called hidden files. So if I say ls-a, I'll actually see there's a directory called .git. And if I were to cd into there, there's a bunch of files in there. Okay, this is where all of your copies of your code, your changes, your log files, and so on and so forth get stored in this directory. If you monkey with this, you can wipe out your entire repository. Okay, so don't monkey with this unless you're doing it purely to experiment and learn. In that case, don't do it on your final project the night before it's due. Okay, but set up a junk account, make some files, go ahead and go crazy, see what's going on in there. But by default, if I say ls, I'm not going to see that. Okay. Okay, so we've initialized this. We want to put this stuff under Git control. We want to take these files and somehow add them to a repository so that later we can get them back. And there's 2 things you have to do. So there's what we call a staging area. So So think of your files sitting over here that you're editing, you're running, and so on. To put them into the repository, we have to do two things. First, we move them to the staging area. And we can put as many things on the staging area as we want. We can take them off the staging area. And then we say, take everything on the stage and push that into the repo. That's called the commit. Okay? So we're going to add things to the staging area, and then we're going to commit our changes. And it's always going to go in pairs. So how do we add something to the repo? Git, add, and the name of the file. And you can do that once for each file you want to add. You can use wildcards like, say, git add star.c to add every file that ends with .c. You could say git add star to take every file in your directory and add that. And that's honestly what a lot of people do, but it's overkill. But no harm in that. So let's be tactical here. Let's git add readme, and let's git add main.c. All right, so those are on the staging area. Now, anytime you want, you can say git status, and it'll show you what's going on. And there's a lot of words here, but basically it's saying there's some changes that need to be committed. And there's two new files, readme and main.c. How do you commit them? Git commit. Okay, so that's the second part of putting things into your repo. So git commit will do the following. It will open up an editor window in whatever editor you've specified, and it will ask you to type in a message. And this message is basically going to be associated with these files in this version. So I'm going to type a message here saying initial version of demo files. All right, 2 files changed, 3 insertions, initial version of demo files. No error messages, you're good to go. Again, nothing has changed when I just say ls. I've got my original main.c and my readme. And if I say git status, nothing to commit, working directory clean, that's what you want. That means everything's been updated. Everything's been pushed into the repository. But if I say, let's make some changes to main.c, let's at least put our include in there, and then we'll put the rest in later. Now if I say git status, it tells me, hey, I've modified main.c. It's not staged for commit yet. So if you say git status and see something like this, it means, oh, I've made changes, I have not pushed them into the repository yet. So what do we do? Git add main.c, git commit.
The git commit -a, does that automatically commit?
I think so. You can also say -m and put in a message, and it'll use that as the message. All right, so what's my status now? Everything's clean. But I can say git log, and it will show me what's been happening in this repository. So at 11:46 and 39 seconds, I did a check-in with the message initial version of demo files. At 11:47, I did another check-in which said added an include statement.
With a typo.
With a typo. And these magic numbers down here, these can be used to pull back the version of your files at a previous point in time. So if I want to go back to the initial version, I could say check out. I could use part of this as the indicator of what version I want to check out, and bingo, my files will be back to the original version. And if I say, oh, I didn't need to go back that far, I only wanted the latest version, I can say check out the repository using this, and now they're in the latest version. Right? Or I could pick something in the middle. If I've got 15 different changes, I could check out some files from one version and so on. So it's a full history of everything that you've done, as long as you're doing these adds and commits along the way. All right, so that's our local version of Git, but it's still just local on this machine. If the server goes away, everything is gone. If I delete this directory, everything is gone. It's just a bunch of files. So what we really want to do is we want to take these things, these remnants of our work, this repository, and we want to push it somewhere outside. We want to push it to an external server. This is what Gitlab is. It's a cloud-based server that we can push these repos into, and it will be there for us, and we can pull things down from there and so on. And it gives us backup in case something happens to this, but it also gives us a way to take our work from here, push it to Gitlab, and then on our home Unix system we can pull it down from there, and we have a clone of what's on here on our own laptop. So we'll play with that tomorrow. We'll go to GitLab, we'll see how to set up a secret handshake so we don't need to use passwords, and we'll see how to push repos out. So we'll be doing that tomorrow.
Hey Nick, can you help me set up